For this next part of the demo, we're going to be showcasing the encrypted container workload capabilities. And so we'll be showing this in two parts. So first, we'll be showing how we can create an encrypted container workload that's secure through a DevOps pipeline. And second of all, we'll show that this encrypted container can only be run on nodes that have been attested with a hardware root of trust and are trusted. So let's start with the first part of it, which is encrypting an image through a secure DevOps pipeline. So for this, we'll be using the OpenShift pipelines, and so we can access this through the OpenShift console. We first have to switch to the developer view by clicking on developer, and we have set up a couple of pipelines here, and the one that we are looking at is the DSOP image scan pipeline. And what this pipeline represents is a secure application pipeline where the applications are scanned and are encrypted only so that they can be executed and decrypted on trusted nodes. So the pipeline is pretty straightforward. It takes a input as a GitHub repository. It builds the image in the repository and then scans it with OpenSCAP. And finally, once the scan is successfully, it encrypts the image with a key only accessible to trusted nodes that have been tested and uploads it to a registry. So let's kick off this pipeline with an application. So we start this pipeline, and we are going to refer to this GitHub repository, which is a UB8 image from Red Hat. And we're going to push it to our registry with UB8 encrypted. So we'll start off this pipeline, and we're going to let it build. Great, the pipeline has successfully completed running, and so now we have an encrypted image, which will only be decryptable on a trusted and attested node. So we're going to now try and deploy this image that we've successfully created. And we are going to do that by creating a daemon set. So if we go into workloads and go into daemon sets, and we are creating this daemon set to show what happens when you try to run an encrypted image on nodes that are not trusted. So we're just going to add the configuration here. And basically, we're going to be using the path of the image, which we just built. So with this, I'm going to create a daemon set. And what this is going to do is it's going to create the pod on every single node in the cluster. So going back to what we talked about in the orchestration demo, we know that the only bare metal machine that has Intel Cycle installed and has a TPM that can be attested is worker number 5. So we see in this case that worker 0 and worker 1 is not able to successfully decrypt and run the image, which is what we expect, because they should not have access to the decryption key. Now let's look at worker 5, and we notice that it's also getting an error image pool. So let's take a look at the error message here. So we further inspect the pod and go into events. We now see an error message saying missing private key needed for decryption. So why is this so? Let's take a look at the node to find out. So going back, let's take a look at the node again. And we see that the node actually has the label trusted equals to false. So it seems like there's something wrong with this node and it cannot be attested. And this is actually what we did in this setup is similar to what we went through in the orchestration demo, in which we had removed a flavor from the attestation profile. So currently this node is not trusted, and therefore we're getting this error because the key broker is not releasing the key to the node because it cannot verify trust status. So now what we'd like to do is to bring the node back to a trusted status so that we can try and run our image that is encrypted. So what we're going to do is we're going to reverse what we did to simulate the failure in the orchestration demo. And we can do this by reinstating the flavor measurement again. So we can make an API call to add the flavor back, which is a call to the iCycle API. And then let's go back to look at the trust status of the node now. So if we now go to nodes and we click on worker 5, we can see that the trust status is now true. So let's check back on the daemon set. Great, and we can now see that the encrypted workload is now successfully decrypted and running on the trusted node.